and range. The domain of a function, so the domain of a graph, is the set of all possible x values for that function. Graphically, the domain is represented as the lower and upper limits of a graph. I may end up going back to change that. The range is the set of all possible y values for the function. And graphically, the range is represented as the lowest and highest limits, so lower and upper limits of the graph as well. So we'll go over these examples. If you still have questions after that, let me know. Some functions have unlimited or infinite domain and range. If you see an arrow on the end of something, so a line that has an arrow, that would be infinite in that direction. Others have a domain and or range that is limited due to restrictions on the allowable values for x or y. So that would come down to could be a whole bunch of different things. You can find it from the equations or from the graph, and we'll talk about that in a minute. When writing the domain and range, we use specific notation. Here's some examples. This little r right here, does anybody recognize that? That is all real numbers. That's all positive and negative values, basically from negative infinity to positive infinity. So that's another way that we would write it, negative infinity to positive infinity. The notation with the brackets and the parentheses. The parentheses indicate that that particular value is not included. So the reason we use parentheses, the negative infinity and positive infinity, is that you can't ever reach negative infinity or positive infinity, so we use the parentheses. The brackets indicate, for example, on this one, that your x values go from -2 to 7, including -2 and 7. So -2 included to +7 also included. A domain of -5 to 5 with the parentheses would be your x values, and I'm just going to do the dash here to indicate we're also talking about the x values, from -5, but not including -5, so excluded, to +5, also excluded. Bless you. So what that means is that every fraction of a decimal towards -5 and towards 5 is included. So -4.99999 is included in that range of values, in that domain of values, but not -5 and not 5. So what would this domain look like? Those would be your x values from what? 1 to infinity. And are we including or excluding 1? Including. Those brackets indicate that we are including it. So x values from 1 included to infinity. And infinity is always excluded. here, on the next one, this is a union symbol. So this means everything basically below 5 and everything above 5, but what's not included in that? 5. So what this would look like on a number line, so here's 5. We'd have an open circle at 5, and it would be everything above it and everything below it. But the x value, for whatever reason, can't actually be 5. So this would end up being all real numbers except 5. So just write this somewhere. I'm going to go ahead and put it down at the, no, off to the side. So brackets and closed circles on a graph or a number line indicate included. If I have parentheses or an open circle on a graph, that would indicate excluded. So something that people really struggle with is isolating just working with the x values and just working with the y values. So the way that I tend to look at it is to basically run the pencil from left to right when I'm dealing with domains. So my lowest x value, if I'm right there, what is my lowest x value? Negative. So I'm looking at part B. Sorry. Negative 3. So the vertical line going up from this, I'm only looking at my x values. So the domain, and is negative 3, is that going to have a bracket or parentheses? Bracket, because that's a filled in circle. So it goes from negative 3, and then I just take that pencil and go over until I hit the end of it. What's my highest x value? 4. Also included. Make sure you're very, very clear in your notation when you're using brackets and when you're using parentheses. To isolate the y variable, you're going to go from bottom to top, always from lowest to highest. And so you're going to use a horizontal line instead. So what's my lowest y value? Negative 5. So I'm looking at that space right there. So range goes from negative 5 up to positive 2. Also included. Domain and range, in case you didn't notice, the way I always remembered which one was which. Domain, range is in alphabetical order, so is x, y. So domain is your x variable, range is your y variable. So what I want you guys to do is take a couple minutes. I'm going to pause the video. Take a couple minutes and attempt these problems. Make sure you're attempting them in pencil, not pen. We'll go over them to make sure you got them clear. And then we're going to sketch one, and you guys will have your assignment to work on. Let's go ahead and go over these. What did you guys get for the domain and range on part A? Negative infinity to infinity. So you can use all real numbers. So that's one way to go, which is interesting to write. Or you can do negative infinity to infinity. And I write the range below because I'm running out of room. Also, negative infinity to infinity. On part C, what is my lowest x value? -1, and am I going to use a parentheses or a bracket? Parentheses. So -1 to 3, parentheses or bracket? Bracket, because that is a closed circle. The range, what's my lowest y value? Negative. Yep, -3. And that's going to be a bracket. And then my highest value on there will be 5 with the parentheses. So remember, always that horizontal, lowest to highest. What did you get for the domain on part D? What did you guys get for the domain on part D? It is. Negative infinity to infinity. Okay, Ethan, I'm going to have you go back to your table. What about the range on this? Yep. The range, 1 included, because our lowest point on that parabola is 1, and then it goes up to infinity as indicated by those arrows. And remember, parentheses always go with the infinity. So, one of the things we talked about briefly last class that I want to point out what these things are. Do you guys remember what those dashed lines are called? Asymptotes. And an asymptote is a value that your x or y values will approach infinitely but will never reach. So, what would I say then about my x values, about my domain? What's my left bound? Yeah, Ethan? Okay. So that takes care of from here to here. What happens after that? Yep. Alrighty. So this is basically saying all real numbers except for 2. So x cannot be 2 would be another way to look at it. But you want to get used to this notation because that's the one that's most frequently used. And then what about the range? Same general idea. Negative infinity up to -3, not included, and -3 up to infinity. Any questions on that? This is how you create your graph when you have a basic domain and range like this. So I have a domain that goes from -3 to 2. So at -3, what I'm going to put is a dashed line because 3 is not included. And at 2, I'm going to put a solid line because 2 is included. On the range, -4, I'm going to have a solid line, and 0, I'm going to have a dashed line. So basically what this is saying, and you can't see it very well because of the pencil, box here, this is where this graph has to occur. So where my two dashed lines are meeting, I'm going to have an open circle, because those are not included. And where my two solid lines are meeting, I'm going to have a closed circle. And then the easiest thing is just to connect one to the other. So that's my graph that meets that domain and range restriction. Some of these other ones are going to have to get a little bit more complicated, and you'll have to get a little creative with them. So your worksheet for this one is going to be pretty quick. You're going to have the next about 15 minutes, a little bit more to work on it, and then I'm going to have you guys take the quiz. So that is section 1.3. If you missed any of those notes, let me know.